In this video, we're actually going to demonstrate how to do the perpendicular bisector for each type of triangle that we see here, both an equilateral, an isosceles triangle, an obtuse triangle, and a right triangle. Notice that this one also counts for the acute triangle, so we're not going to reduplicate him here. Okay. The perpendicular bisector, of course, just runs through the middle of one edge and perpendicularly. And it's just the perpendicular bisection construction that we've done before. So in each case, we'll just take our perpendicular bisection construction and demonstrate that for all of them. It looks just a little bit different. Okay. So in the case of the equilateral triangle, you'll see that the perpendicular bisector actually runs through the other vertex. Okay. For this guy, okay, the obtuse triangle, clearly it's not going to be running through the other vertex. Okay. So we again take our points and sweep them out. And we construct our perpendicular bisection line, which just goes there. This is our perpendicular bisector just in the actual triangle. Okay. For this guy, okay, it should be fairly obvious that the perpendicular bisector that runs through the opposite side to the single angle of an isosceles triangle will also run through the vertex, just like it did for the equilateral triangle. But we will again demonstrate that that's the case. Okay. So again, we just have our perpendicular bisector go straight through. It again intersects the end vertex. And then we look at this guy and we say, okay, well, we want a perpendicular bisector, but it's also one that happens to be parallel to this guy. This one is special, the right triangle. Okay? Not the way in which you do it, but kind of what happens and what's important. Okay? The perpendicular bisector, okay, for this guy, when we're not talking about the hypotenuse side, okay, has a special property. It actually cuts the triangle in a lot of ways, bisects it. One, these two are going to be congruent by definition, by definition of the perpendicular bisector. But strangely enough, the other two are as well. So this and this are going to be congruent, as are this guy. Well, and I suppose the other half of him. Okay? So this length is really going to be double what this guy is. Okay? So those are the properties of bisectors. You could draw, again, just like the altitudes and the medians, all three, and they do meet at a similar location, just as the medians and the altitudes for the orthocenters and incenters, etc.